Triangle ABC has AB is equal to 13, BC is equal to 14, AC is equal to 15. Let P be the point on AC such that PC is equal to 10. There are exactly 2 points D and E on line BP such that quadrilateral ABCD and ABCE are trapezoids. What is the distance DE? Let's start with drawing our triangle, which is ABC triangle here. This is A, this is B, and this is C. We have AB is equal to 13, BC is equal to 14, and AC is equal to 15. We have a point P on AC, and we have a line BP, and what we know is PC is equal to 10, then AP is equal to 5. There will be 2 points on this line BP, and we are going to form a trapezoid. And the first one has to be parallel to, trapezoid has a pair of parallel sides. Let's say this point is D, and we have a trapezoid ABCD, this is parallel. And we have another trapezoid. If we draw a parallel line to AB, we can draw another parallel line to AB, and it will be somewhere here. Let's say this is E. This has to be parallel to AB. And we have another trapezoid ABCE. We can also draw this line. This is the trapezoid here. And we are looking for the distance between D and E. I'm going to solve this problem using similar triangles, and let's figure out some of the lengths here. The first one I can figure out, this is 5. I have similar triangles here. This APD and PCB, they are similar. And the similarity ratio is 5 to 10, which is 1 to 2, and BC is equal to 14, which means AD is equal to 7. This is 7, half of 14. The next thing I'm going to do, I'm going to just make more similar triangles, which is I have here another similar triangle. This one is, since AB is parallel to CE, these two triangles also are similar. Symmetry ratios again 5 to 10, and this time AB is 13, and that makes CE is 13 times 2, which will be 26. Next thing, I'm going to drop an altitude from A to BC. Let's drop an altitude. This is an altitude here, and I'm going to figure out this H. I can figure out this H using Pythagorean theorem. I have here A, B, and C triangle. I just drop an altitude from here. And this is 13. And let's say this is K. And this will be 14 minus K. And this will be 15. I am looking for what is that height. And let's write the Pythagorean theorem, the triangle on the left, number 1, number 2. Triangle on the left, Pythagorean theorem, K squared plus H squared is equal to 13 squared. Then H squared is equal to 13 squared is 169 minus K squared. And if we write the Pythagorean theorem on the right triangle, which is H squared plus 14 minus K squared is equal to 15 squared. And we have H squared plus, we have to square a binomial here. 14 squared is 196 minus 14K, double it, it's going to be minus 28K plus K squared is equal to 225. And if we kind of solve for H squared is equal to 225 minus 196, it's going to be 25 plus 429. Plus 28K, and I will take the K squared to the side minus K squared. Now these H squareds are the same. This one is equal to this one. I will equalize them and find H. Let's equalize them. It will be 169 minus k squared is equal to 29 plus 28k minus k squared. Good thing, the k squared cancels out. And we have 28k. If we subtract 29 both sides, 140 is equal to 28k. And then divide both sides by 28, then k is equal to 5. And this means this is equal to 5. I see 5, 12, 13 triangle. Actually, we can skip this calculation if we kind of try some Pythagorean triples, 5, 12, 13. And the other triangle is just scaled by 3, 4, 5 triangle. If you scale by 3, 3 times 3 is 9. 5 plus 9 is equal to 14. We can skip this calculation if we know some triples. All right, let's put what we have found on this triangle here. We just find this as 5, h is 12, and I'm going to kind of draw a rectangle here now. Let's draw a rectangle, find a good color. You have height here. It's going to be a rectangle. It's going to be a little bit down here, please. Rectangle. And then I'm going to draw from here to there. There will be a rectangle here. All right, this will be 12. This will be 5. And this will be, actually, let's figure this is 13. So this has to be parallel. There's a parallelogram. There's a parallelogram there. Opposite sides are congruent. So this is 13. This has to be 13. And since this is 26, kind of, I have the other side, this one from here to there is also 13. And if this is 7, this one is 14, 7 minus 14 minus 7, this will be 7. And finally, I'm going to draw from here to there. We will have another right triangle here, which is there will be similar. Since this is a rectangle, this is 12, and this one is 12 as well. And this is also 5, 12, 13 triangle. This is a right angle here. And we can see another similar triangles from here, which is going to be this triangle, similar to the bigger one, this bigger triangle. And the ratio of the similarity is 13 to 26. We can see 1 to 2, and which means this has to be 5, 5 to 10, and this has to be 24. Okay, what we have here, we are very close to our solution. Let me take it a little bit down here. We are looking for the distance DE, and I'm going to kind of from here to there, if I figure out this length, let's make it right, like this length. And if I figure out this length here, I can use the Pythagorean theorem and then find my distance. Okay, that distance is, since this is 12, 24 minus 12, this length is 12. And this is here 5, this 7 plus 5 is, that's also 12. So we have 12, 12, and DE, which is 45, 45, 9-degree triangle. So DE has to be 12 square root 2, which is answer choice D.